Okay, dear student, today our topic is interference of sound. Interference of sound means when two sound waves are passing through the same point in the same time, interact each other and produce sometimes loud sound and sometimes faint sound is called interference of sound wave. Now we will explain it by this example. This one is amplifier or tuner. We have connected two speakers with the tuner and the same sound waves having same frequencies are produced by the both speakers, and the listener is standing at the distance of 2 meters from the speakers. Sometimes he listens maximum sound, loud sound, and sometimes minimum sound means faint sound. Likewise, this graph shows the maximum and minimum sound wave due to the interference of two waves. Both the waves interfere each other and sometimes produce loud sound, sometimes produce faint sound. So this is known as the interference of sound waves. Now we can write it. Interference of sound is explained by connecting two speakers with the same amplifier and a listener is standing at the distance of 2 meters from the speakers. Sound waves of both the speakers interfere each other and the listener sometimes hears maximum sound and sometimes minimum sound due to the interference of wave. So these are the interference of sound waves. Now come to the applications. In daily life we hear these interference. So first one is resonance of sound wave. The interference of sound wave when two waves having same amplitude and frequency but opposite in direction produce a loud whistling sound is called resonance of sound. So in this phenomenon there are two waves, their direction is opposite but their frequency and amplitude is same. Both the waves interact each other and produce resonance of sound, which is the loud sound, loud whistling sound. Now we can explain it by this diagram. So this is beaker of water and this one is glass tube. It is placed in the water of beaker and a vibrating tuning fork brought near to its mouth. Sound waves by the tuning force enters into the tube and strike with the level of the water and return back. When they return back, they interfere each other and produce large magnitude, which is the whistling loud sound. It is known as resonance of sound. Mean amplitude of the sound wave sometimes increased by the variation in the volume in the level of the water. So the heavy amplitude or large amplitude it produced, which is the whistling sound of the waves, so it is known as resonance of sound. Now we can write it in the simple form. When vibrating tuning fork brought near the mouth of a tube in water, sound wave entered in the tube and strike the water reflected back. Both the waves mean incident wave, which is going from the vibrating tuning fork and striking with the water. That waves are coming from the tube. So both the waves interact each other here and produce a large loud whistling sound, which is known as resonance. Second one, the application of resonance, then the application of interference is beat. What is beat? when two sound waves having same amplitude and direction but a little bit difference in frequencies, meaning two waves, their amplitude and direction is same, but a little difference in the frequencies interfere each other due to periodic variations, produce sometime a loud sound which is called beat. So we can explain it. These are two sound waves. Wave 1 which has 10 Hertz frequency and wave 2 which has 8 Hertz frequency. Both the waves interfere each other and sometimes produce loud sound which is known as beat. So this is the explanation of beat, means the application of interference is beat and resonance. These are the two phenomena which are the application of the interference of sound. So it is the end of the chapter. In the next class we will solve the numerical of the chapter. Thank you.